Welcome again to Let's Talk Chemistry with Pastor Dan. We are looking at pH. Now, in order to do pH, we're going to do a little derivation. We're going to start with an equation, and that's going to show us how we come up with other values that we're going to use later. So here I have the dissociation of water. Water can break down in equilibrium, means going forward and backwards, to both hydrogen ion and hydroxide ion. Now, it's a very, very weak acid. So as a result, not much of it breaks apart. If we do that, we can get a value which we call Ka. Now, Ka just means equilibrium for acids. And you'll notice we have the products here like we did for equilibrium, but I don't have water on the bottom. The reason why I don't have water on the bottom is water is a liquid. Liquids are pure. Concentration means it's part of something in something, and since it's all water, there's no concentration, so I can't have that. So if I take this value, which is 1 times 10 to the minus 14, a very, very, very small number, 0.13 zeros and a 1, that's how little it dissociates. We're going to find hydrogen ion and hydroxide ion. Now, I can try to make that easier using a value on your calculator called logarithms. Whoops, before I do that, talk about what pH is. Whoa, I want to go back. No, I didn't finish variation. Logarithms. Now, logarithms are a scale based on 10. So if I go from 1 to 2 on logarithms, I didn't go up 1, I went up 10. 1 to 3, I went up 100. 1 to 1,000. 1 to 3. 1 to 4, it's 1,000, 3 zeros. Now, because it's negative, we're going decimals. So if I'm going from -1, 0 to -1, I'm going down to a tenth. 0 to -2, I'm going to a hundredth. So we're getting very small numbers. If I take the values here in logarithms and I multiply them, I can do the same thing as, I keep doing that, I'm sorry. I can take that and separate them by adding. That's a rule of logarithms. If two numbers are multiplied, I can add them separately. Now, that value there, negative log, is called 14. The negative log of hydrogen ion we call a value of pH, and negative log hydroxide a value we call POH. So that's the derivation I use to get from here to there, and that's these 1, 2, 3, 4, 5 equations I'm going to use to later. So let's make sure we identify. I've been trying to get to this over and over again. I apologize. So let's look at a pH and POH. pH is defined as a measure of acidity. Now, in reality, I can go below 0, I can get negative, I can go above 14, but in general, we say it's 0 to 14. And POH, which is a measure of alkalinity, does the same thing, 0 to 14. Well, what's in the middle? In the middle, 7 is neutral. And the only thing that's really neutral is distilled water, not regular water, not tap water, distilled water. Now, rainwater is slightly acidic. That's why we get acid rain. Human blood is slightly basic. It's like, depends on the person, between 7 and 9 is usually pH of blood. So that means 0 is extremely strong acid and 14 is extremely strong base. Now, POH, which is alkalinity, basically takes the pH scale and flips it. So where pH 0 is a strong acid and 14 is a strong base, we're going to flip them, and 0 is a strong base and 14 is a strong acid. All right, so let's look at a problem. I'm going to use these 5 equations. I used pH and POH. I looked at for negative log of hydrogen ion and negative log of hydroxide ion. pH plus POH is 14. To find hydrogen ion, then, I'm going to take 10 raised on the calculator. So on your calculator, you see the log button above it, 10 raised to the, you get that, and put the POH, that'll give me hydrogen ion concentration, hydroxide ion, 10 to the minus POH. All right, so let's try one. Let's say we're going to work with HCl. Now, when we dissociate HCl, we're going to get H plus and Cl minus dissociation. If the concentration of acid is 0.002345, this molar right here, because this is 1 to 1, the acid concentration is, hydrogen ion concentration is also 0.002345. And the chloride ion concentration would also be 0.002345 molar, but we don't care about that. We're looking at hydrogen ion. So Hydrogen ion is 0.002345. That's the first one I need to find. All right, now, once we have hydrogen ion, what are we going to solve for next? Well, hydrogen ion, we said right here, will give us pH. So if pH is negative log of hydrogen ion, just plug it in. Use your calculator. Again, it's a log scale. It's 10, but on the calculator, it's just a button. Press it. Put in negative log 0.002345. Hit equal. When you do, you should get 2.630. Now, you might get 2.63. The number rounds up to 3 and the 0. But I need 4 sig figs. The 0 is there. Now, how are we going to find POH? Well, POH plus pH is 14. That equation right there. So if I know that, I can rearrange it to say POH is 14 minus pH. And that 14 there is infinitely significant, as many sig figs as we need. So we take 14 minus 2.630. And remember, this is subtraction. Rule for sig figs is subtraction, last filled column. So when we subtract it, we get 11.370 in the end because that is the last filled column. All right, so we found hydrogen ion, we find pH, we found POH. Last thing we got to find is hydroxide ion. It says over here hydroxide is 10 to the minus POH. So we're going to say 10 to the minus POH, 10 to the minus 11.370. So in your calculator, type in log negative 11.3370. And I have 5 sig figs. So my answer is 4.6258 times 10 to the minus 12. But this is a concentration, so I do need molar, and that's my answer. So we have 1, 2, 3, 4 problem answers there. All right, let's try this one. This time I want to do sulfuric acid. I want to do the same thing. Hydrogen ion, hydroxide ion, pH, POH. So let's start with the acid. Sulfuric acid is H2SO4. Ic acids are 8s. Going to find hydrogen ion and sulfate. Balance it up, put a 2. So again, same thing. If it's 0.00344 molar, because that's 1 to 2, hydrogen ion is going to be multiplied by 2, and we get 0.00688 molar for the concentration of hydrogen ion. To find pH then, pH is a negative log of that value, so you plug in a calculator, negative log, number in there, equal 3 sig figs, should get 2.16. To find POH, we're going to do the same thing we did with pH last time. We found POH. We found, I did the same thing. We found POH by doing the same thing. 14 minus pH, again, sorry about that. 14 minus 2.16, last field column. That's infinitely significant, 14. So we get 11.84. All right, now, to find hydroxide ion concentration, it's 10 to the minus 11.84, 4 sig figs. I'm going to get 1.445 times 10 minus 12 molar concentration. There we go. All right, let's try this one then. Now, we're getting a little bit more complicated here. We're going to do hydroxide. We're doing base instead. So the reaction here is going to be aluminum hydroxide forms aluminum plus hydroxide. So if I want to find hydroxide again, this is 1 to 3. So they take this concentration for hydroxide and we're going to multiply it by 3. So we're going to get 0.001367 multiplied by molar because that's this value, 0.00004556 molar times 3. To find POH then, is a negative log of that value. Plug in the calculator, we get 3.864 since I have 4 sig figs. To find the pH then, this is where we're going to do reverse, where we solved for POH last time, it's 14 minus pH. To find pH this time, it's 14 minus POH. So we're going to get 10.136. And then to find hydrogen ion, we're going to do the same thing, 10 to the minus pH, 10 to the minus 10.136. And I'm going to get 7.3114 times 10 minus 11th molar. Because I have 5 sig figs, have to have 5 sig figs there as well. Molar because it is a concentration. All right, so let's try this last one. Try this one on your own. Pause the video, see what it comes up with. Just so in case you're stressing out, silver hydroxide. So right there, pause it, see what we get. I'm just going to give the answers. Okay. Ready? Practice. Here we go. First thing I'm going to find is hydroxide. It's going to be 0.0007883 molar because it's the same thing. It's 1 to 1. Then we're going to find pH 10 to the minus that value, 3.108. pH 14 minus 10.897. And then 10 raised to that 1.2677 times 10 minus 11th back to molar because it is a concentration. All right. Hopefully that wasn't too bad. Take care. God bless.